moving on to the embedded system software. Why this software is to be studied at this stage? What is the need? An embedded system, whenever the hardware has to drive, there should be an associated software. So therefore, this embedded software will deal with what are the various components in the software that must be available in order to run the embedded system. So an embedded system needs software to drive any operation. If it has to perform, it needs a software. So here this particular figure, if you observe, it has the embedded system software, complete embedded system. It should accommodate with 4 different components in the software. What are those? The 4 components, you can look the baseline or the base block. It is a hardware device, that is what we have already studied, which has to be supported by the software. In the software, what are the various components? You can look at 4 different components in the software must be there in order to support for any application by this particular embedded system software. What are those 4 blocks? One is the initialization. The next one is device drivers. The third component is the operating system. Fourth component is the application. Now let us see what is the importance of each of these components. When you go for this very first component in an embedded system software is the initialization. Whenever any system has to be initialized, it should be stored. The complete software should be stored with, the system should be stored with some code. That code is termed to be an initialization code. The initialization code is the first code executed on the board and is specific to a particular target. As soon as you power on, there should be an initialization of the system of the target board. So therefore, the initialization code is very much essential. If you look at the next component importance, it is the operating system. This operating system provides an infrastructure to control applications and manage hardware system resources. Any embedded system, for its functionality or any device in turn, if it has to operate, it has to have the operating system. There are many different operating systems which we'll discuss in the further slides. If you will go for the third component is the device drivers. So without device drivers, you cannot run any of these specific applications. So therefore, you need to have, suppose if you want to connect a printer interface, if there is no relevant driver on the operating which is not available in the operating system, then your printer cannot be connected and cannot be cannot see the function of your printer if that driver is not existing. So therefore, the third component that has to be there within the embedded system software is the device drivers, or the third component controls a particular type of device that is attached to a computer. So example, I told you it is a printer. Printer, whenever it has to be it has to be used by the embedded system for printing any of the information. It needs the associated drivers. So your operating system should also, embedded software should have the drivers which are relevant to a particular device which is under use. The fourth component you can see is the application. This performs one of the tasks required for a device. Application can be in anything, whether you go for a wireless or network device or mobile phones or anything. So it should have an application layer software. That software must be supporting the that must be supporting for an external device to interface and interact properly with the embedded system. Now, the very first component what we have seen in an embedded system is the initialization. in this initialization, what is that initialization is nothing but a code. What is this code is all about? It is also termed to be an booting code. Boot code or the initialization code. What is the function of this particular boot code? It is it takes the processor from the reset state to a state where the operating system can run. So whenever if there is no initialization software, your operating system cannot run in any embedded system. So therefore, the boot code, it must be available in the embedded software. The initialization, the other function of this initialization code is what? It handles the number of administrative tasks prior to handling control over to an operating system. Before it gives a control to an operating system to take care the devices or take care specific task, your initialization code should handle number of administrative tasks. So therefore, initialization code is very much important. These tasks, what are the tasks this initialization code or boot code will do in an embedded system? The first task that it will do is an initialize hardware configuration. Diagnostics is the next level of task that is performed by initialization code, and the third one is the booting task. So now let us see what this initial hardware configuration will do. This particular initial configuration code, whatever we write in a boot code, involves setting up of the target platform so it can boot the image. Any program, if it has to be booted or if it has to be taken care by the operating system, there should be an hardware configuration. So that hardware configuration which will be taking care, that is the boot code that will take care. The target platform itself comes with a standard configuration, but this configuration normally requires modification to satisfy requirements in the booted image. So the initialization code, what it does, see, after a reset button is pressed, it will be, the memory contents will be in a somewhat organized manner, but that particular organized contents have to be reorganized. So whenever that reorganization of the memory contents during the booting of any program, this initialization code hardware configuration will support. For example, you can see there is a memory before executing the initialization command and after executing the initialization commands. So how it has been required, this is always the reset upon conditions. You can see the embedded systems memory, but whichever the required way, that will be the after executing that initialization or hardware configuration. If you go for the next task, that particular embedded system or the initialization code or the code that will do is an diagnostic. So there should be three different programs in the boot code. One is that hardware configuration related code has to be there. The second one is diagnostic code should be available. The third one, it is the booting code also. All these three combined functions is a function of an initialization or boot coding. The diagnostic embedded system software does what? It embedded in the initialization code itself. It is a part of your initialization code or boot code. What's the function of this particular code is that once the system has been restarted and reinitialized according to the hardware specifications, this diagnostic code will be run onto the system, and this particular diagnostic code is to test the system by exercising the hardware target to check if the target is working in working order or not. If it is not in working order, see when you boot the system or when you reset the system, it starts displaying the messages. If there is some bad sectors in the memory, that you can directly see on the screen once your system has been rebooted, you can observe these things in your personal computers or your laptops. Okay, such facility the user can get only if the initialization code or good code is having an operating code which is supporting for the diagnostics. So this diagnostic code function is what? Whether the system is in working order or not, that will be the function it will test. The primary purpose of diagnostic code is called identification and isolation. The third component which is available in the initialization code is the booting. Booting involves loading of an image and handling control over that image. Any program, booting is nothing but any program, if it has to run on a computer like operating systems which includes Linux or Windows or whichever platform you consider, that complete program which has to be booted first. So that booting code which is available in the initialization code itself. Coming to the next component which is available in the system software is the operating system. So this operating system, it is a process prepares the hardware for an operating system to take control. Okay, now when you look at this operating system, there are different operating systems which you can see which are associated with any of the computing devices. For example, if you go for your mobile, what are the various operating systems you have? Android operating system, there are many, right? So iOS, all these operating systems which you can see along with the after the initialization process and code associated with that is the operating system. When you look at the any ARM processor, nearly it supports more than 50 operating systems. We can divide operating systems, all the operating systems into two different categories. One is real-time operating system and the other one is the platform operating system. When this real-time operating system, what is the exact difference between the real-time operating system and then platform operating system? Let us first try to see. Real-time operating system provides guaranteed response times to events. Any real-time event, if it is happening, if the operating system is real-time, the response to the event will be happening with this particular real-time operating system. Different operating systems have different amount of control over the system response time. How fast the operating system, how flexible is the operating system, that will be the response time to our application. You can see in the real-time operating system. Here also there are two different types of real-time operating systems. One is the hard real-time operating system and the other one is the soft real-time operating system. In the hard real-time software operating system, the real-time application requires a guaranteed response to work at all. But when you go for this particular soft real-time application, when you are working with the soft real-time operating system, here requires a good response time, but the performance degrades more gracefully for the if the response time overruns. So all these